I'm Philip Mayeux, Professor of Pharmacology and Toxicology, Department of Pharmacology and Toxicology, University of Arkansas for Medical Sciences. A patient who develops a severe bacterial infection, for example from pneumonia or perhaps an injury to the gut where there's leakage of the bacteria from the gut, can develop a systemic inflammatory response that can lead to a condition known as sepsis. And if it's severe enough, the sepsis can generate septic shock, where there's a dramatic fall in blood pressure. Now, sepsis is the 10th leading cause of death in adults 65 years of age or older, but it's in fact the second leading cause of death in kids 1 to 14 years of age. So it's a huge medical problem. Around 750,000 individuals develop sepsis every year, and unfortunately the mortality rate is nearly 50%. Now, if there is accompanying kidney injury, which often happens in sepsis, that dramatically increases the mortality rate to nearly 70%. As a pharmacologist, I want to understand what's happening to the kidney during sepsis to hopefully uncover new therapeutic targets to help protect the kidney and reduce mortality. Now, therapy for sepsis has been difficult because the mechanism leading to development of sepsis is poorly understood. Current therapy is primarily supportive and obviously not very effective. We use two approaches in our research. The primary one is intravital video microscopy, where we actually can image in real time blood flow into the kidney and the surrounding cells. And we found that after sepsis there's a very rapid and dramatic fall in capillary perfusion in the kidney, and this actually leads to pockets within the kidney where the cells become starved for oxygen. And this, we believe, ultimately leads to injury of the tubules. Now, the tubules are those structures in the kidney that generate urine, they eliminate waste, and they also help regulate our water and salt balance. So it's extremely important to protect that region of the kidney. We've also found through our intravital microscopy that we can use different probes to look at oxidant generation. Nitric oxide and superoxide are both generated in the kidney during sepsis. Now, if either one is generated alone, that's really not a problem. They're not particularly toxic. But what happens is during sepsis, they're generated at the same time, in the same location, in this peritubular capillary microenvironment. And when that happens, they chemically combine to produce peroxynitrite, an even more powerful oxidant. So these findings of the oxidant generation have led us to investigate new therapeutic drugs, particularly the oxidant scavengers and those that even scavenge peroxynitrite. And so we're very interested in this line of research to develop new therapies to help protect the kidney again. So we've also found that the pediatric kidney responds differently during sepsis than the adult kidney. And in fact, we're very interested in understanding why it is that the pediatric kidney may be more susceptible to damage during sepsis than the adult. One of the best things about being a pharmacologist is having the opportunity to uncover new therapies that help save patient lives. It's extremely exciting and fulfilling. If you'd be interested in pursuing a graduate career in pharmacology and toxicology, please contact me or one of our pharmacology or toxicology program directors.